When ALMA listened to 3i Atlas, nobody expected a thriller. They expected the usual Comet soup, carbon monoxide, water, dust, the boring classics. But the first spectrum came back with lines that didn't belong in that story. Not rare, not unusual, just wrong for a comet. At first it looked like noise, a faint spike where there shouldn't be anything. The kind of thing you dismiss at 2 a.m. and forget by morning. Except the spike repeated. Same frequency, same shape, same narrow width, like a clean note played twice in a room full of static. That's when the ALMA team stopped calling it a glitch and started calling it a signature, because glitches don't stay loyal to one exact place. They ran another observation window, different calibration, different weather model, same target, and the same line was waiting for them again. This is the part most people don't understand. ALMA doesn't take pretty pictures first. It listens to molecules talking in millimeter light. Every molecule has a voice, a set of tones it can sing, and when those tones show up, you can't pretend you didn't hear them. So the team did what scientists always do when the universe acts weird. They tried to make it go away with boring explanations. Maybe a background galaxy, maybe a stray masser, maybe a calibration leak, maybe the line belonged to something behind Atlas, not Atlas. They checked sky catalogs, nothing lined up. They rotated the field. The line stayed with the comet like it was glued to the moving target. Then they did the most important test, Doppler shift. If the source is Atlas, the line should shift with its motion. It shifted exactly as expected. The fingerprint moved like it was riding on 3i Atlas, not sitting in the distance pretending to be relevant. That was the moment the room changed, because now it wasn't a cosmic coincidence. It was local. It was attached. NASA didn't tweet it. NASA didn't do a press splash. Because you don't announce, we found chemistry that doesn't fit. You verify, you double verify, you invite someone else to try to kill your result in the cleanest way possible. So JPL got involved, not to write poetry, but to check if any spacecraft data showed a contamination source. DSN logs were clean, no strange transmitter events, no obvious interference pattern, nothing that would paint a fake line onto ALMA. Then the ALMA team looked at the line width again, and that's where it got creepy in a quiet way. Comet gases usually look messy, broader profiles, turbulence, multiple components, natural chaos leaking into vacuum. This line was narrow, too clean, like it came from a controlled release instead of a boiling surface. And if it's a controlled release, it suggests a nozzle, or a confined pocket, or at least a source that isn't just sunlight cooking ice. So they searched for neighbors. If one wrong molecule is there, others might be hiding nearby, too faint for casual scans. They stacked hours of data, they dug deeper, and more lines appeared, faint but consistent like a chord building one note at a time. Not a comet chord, a strange chord, the kind that makes you stare at a molecular database and keep scrolling, hoping to find mercy. Because some of the candidates were the kinds of molecules you don't expect to survive inside a dirty snowball for billions of years. Stuff that should break apart, stuff that should react away, stuff that should never stay stable in the cold long enough to matter. And yet there it was, singing in the dark, coming from an interstellar visitor that keeps showing up with new ways to feel wrong. Now here's the trick ALMA can do that changes the whole story. It can map where the emission's coming from, not in perfect detail, but enough to tell if it's a fuzzy coma or a tight source. The emission wasn't spread evenly, it was clustered. A bright knot near one side of the nucleus region, offset like a specific vent. Not the whole coma, not a spherical haze, a localized origin, like a seam in the body where something escapes on schedule. So NASA asked the obvious next question, does it pulse? Because if the chemistry is coming from a seam, it might turn on and off with rotation, like a lighthouse made of molecules. They ran time-sliced stacks, and the emission did change. Not wildly, not exploding, but rising and falling in a rhythm that matched a rotation window, like the source had a preferred face. And once you have rhythm, you get the worst kind of pattern. A pattern means you can predict it, and if you can predict it, you can test it, and if you can test it, you might learn what it's hiding. Webb was pulled into the loop, because if strange molecules are venting, you might see heat, even a faint trace around the vent region. Webb's infrared data didn't show a blazing hotspot, it showed something more unsettling. A thin warm streak on the night side, faint but structured, like heat was being routed under the surface instead of arriving from the sun. That warm streak lined up with the ALMA emission direction more often than chance should allow. Not perfectly, because space never gives you perfect, but enough to feel like two instruments were describing the same internal plumbing. Now let's be clear about what made the chemistry feel alien. It wasn't that ALMA detected life, it wasn't that the molecules spelled a message. It was the combination, the ratios, the cleanliness, the way the lines behaved like they came from a controlled environment. Comets leak, they don't regulate. Comets sputter, they don't time their releases like a metronome. And comets don't usually carry molecular signatures that look like they belong in a lab more than in a frozen rubble pile. So the team did the cruelest test of all. They tried to recreate the signature using known comet chemistry models, cold formation pathways, radiation processing, trapped volatiles. The models couldn't land on the same mix without breaking something else. To get those molecules, you had to assume conditions that don't match a normal comet interior. Either the composition is wildly unusual, or the environment inside is not what we think a comet interior is. And that's the story pivot. Because once you say the interior isn't normal, you've opened the door to everything else Atlas has been hinting at. The drift anomalies, the shadow-like null patch, the nightside warmth that shouldn't exist. This isn't one weird reading, it's multiple instruments touching the same invisible structure from different angles, like blindfolded hands feeling the same machine. So now the question isn't what molecule is it? The question is, why is 3i Atlas producing chemistry that looks too clean, too structured, too selective to be a simple accident? And why does it keep showing up in the same place, like it has an exhaust port and not just a random crack? NASA didn't treat the first strange line like a discovery. They treated it like a trap, the kind the universe sets when you're tired and overconfident. So ALMA widened the net, more bands, more hours, more redundancy. If the chemistry was real, it would survive a harder interrogation. They ran a multi-band sweep, like a forensic scan, hunting for a full molecular sentence, not just one suspicious word floating in noise. And the deeper they went, the stranger the grammar became. Some lines match what you'd expect from an icy visitor. CO, simple organics, a faint signature of dust-driven release. But layered on top was a second set that didn't feel like comet breath. It felt processed, not ancient, not primordial, processed like something had been heated, reacted and sealed away, then opened on a schedule. ALMA's advantage is cruel here because it doesn't care about your narratives, it cares about spectral spacing. A molecule either fits the spacing or it doesn't, and one candidate fit too well for comfort. Sodium chloride, salt gas, not salt dust, not salty ice grains. Gas phase, NaCl signatures, the kind you see in hot environments, not on a cold rubble body. You can freeze salts into ice, sure, but turning them into a clean gas signal usually asks for heat that comets don't casually generate. So the first reaction was denial. It must be something else, a catalog coincidence, a mis-ID, a background source wearing a mask. But the Doppler shift followed Atlas again, moving with its velocity like it was bolted onto the object's motion. And the emission wasn't wide and messy either. It was narrow, stable, almost surgical, like a leak from a confined pocket. That's when the conversation turned from what molecule to what environment. Because chemistry is an environment report, a molecule is a witness and it tells you where it's been. If NaCl is present as gas, something inside Atlas is getting warm enough or shocked enough to liberate it cleanly. Warm enough for salt to behave like a volatile. Shocked enough to knock it free without making everything else look chaotic. NASA asked Webb for a synchronized pass, because if a hot pocket exists, infrared should whisper about it, even if the visible looks innocent. Webb didn't see a bright flame, it saw a thin thermal bias that kept returning to the same side like a warm scar under the skin. That scar lined up with the ALMA knot again, the same offset region, the same vent face, the same suspicious loyalty to one geometry. So now you had a chemical vent and a thermal seam pointing to the same place? And if you're thinking, maybe it's just sunlit heating, the timing ruined that comfort. The strongest NaCl signature peaked when the region should have been rotating toward darkness, not into sunlight. That's the kind of detail that makes you stop calling it surface heating. Because sunlight doesn't peak on the night side, internal routing does. JPL tried to rescue the story with a natural mechanism. Sublimation pressure builds, cracks open, trapped pockets release in bursts. That can happen, comets do outbursts, they split, they vent. Nature is violent enough to fake intention sometimes, but the ratios didn't match a simple crack. The NaCl line rose with a partner line that suggested a second hot chemistry component, the kind that implies reaction pathways. Not just stuff escaping, stuff being made. ALMA's data hinted at chlorine-bearing companions, faint signals that only make sense if the local mix is not a standard comet mix. That implies selective storage, layered composition, or a region that's been chemically curated by conditions we don't usually grant comets. Now here's the move NASA made that you only make when you're nervous. They asked for independent confirmation, not from another optical telescope, but from another millimeter facility. Different system, different pipeline, same target window. Because if two arrays hear the same impossible note, it stops being an ALMA ghost. The second facility reported a compatible feature set, weaker, but aligned enough to harden the case. So the alien chemistry label started circulating internally, not as sci-fi, but as shorthand for chemistry not predicted by comet models. That's the key difference. It wasn't a claim about origin. It was a claim about expectation failure. And expectation failure is where the real stories live. because comets are supposed to be dirty archives, cold storage vaults that leak the same simple volatiles when heated. 3M Atlas was acting like a vault with a hidden lab inside, releasing compounds that feel like they were through a different history. NASA built a compositional fit model and tried to force it into known families: Oort comets, Kuiper belt objects, interstellar analogs. The fit kept breaking unless you added a new ingredient: a warm zone, a pocket that periodically hits higher temperature or higher energy density than the rest of the nucleus. And once you add a warm zone, you've created a physical question you can't dodge. What maintains it? Radiogenic heat isn't strong enough for this cleanliness. Frictional heating would be messy and inconsistent. Solar heating would track illumination, but this tracked phase like a routed cycle, like a loop that can run without direct sunlight. So NASA checked rotation state again, looking for tumbling that could expose an unusual face, a mineral seam, a dark absorber patch. The rotation was stable enough to be boring, which means the chemistry wasn't just "we saw a weird side." It was the same side behaves weird every time. That's where the story turns hard. Because repeating chemistry from a fixed vent means structure, and structure means the interior isn't a random snowbank. It's layered, partitioned, possibly sealed into compartments that open and close as pressure and phase align. And if compartments exist, they can maintain environments that are not typical comet interiors. A dry pocket, a salty pocket, a reactive pocket, a pocket that keeps certain molecules intact until release. That doesn't require magic, it requires architecture. The kind you get when a body forms under unusual conditions and stays intact long enough to keep its internal map. Now combine that with the other anomalies you've heard about Atlas. The night side heat seam, the propagation weirdness, the shadow-like null patch that behaves like a boundary. Suddenly, chemistry that doesn't belong doesn't feel isolated. It feels like one more sensor touching the same hidden system. And the scariest part is how calm the data looks. No explosion, no fireworks, just clean lines, narrow profiles, consistent phase, like the comet is doing something controlled without trying. So NASA's next step was inevitable. They planned a long baseline chemistry watch, not one night, not two, but a full rotation series to see if the hot molecules migrate. If the knot migrates, it's surface. If it stays pinned, it's internal. And early results pointed to pinned. Pinned means the vent is not an accident. Pinned means you can predict when the chemistry will speak, which means you can time your instruments like you're listening for a door to open. NASA did what you do when a system keeps repeating. They stopped chasing the shock and started logging the rhythm like it was a heartbeat. ALMA ran a full rotation watch on 3i Atlas, dividing the timeline into slices so fine it felt obsessive. Same bands, same calibration discipline, same molecular targets, over and over, until repetition became the only honest judge. And the vent behaved like it had a schedule. The hot chemistry lines rose as the same face rotated toward a specific attitude, then fell as it passed through, like a valve opening briefly. That alone is weird for a comet, because comets don't normally gate their release that cleanly. But what made it worse was how tight the gating looked. Not a soft ramp, not a smeared peak, a rise, a stable plateau, and a drop, like the source was limited by geometry and not by gradual heating. JPL tried to frame it as topography, a vent shadowed from sunlight, pressure building, then venting through a crack like a tiny volcano. It can happen. It's not impossible. Nature can mimic structure when the conditions are right. Except the valve opened even when the region was rotating into darkness, and the plateau stayed too stable for a chaotic crack. Then came the night that broke the model. Same rotation phase, same window, same predicted rise. ALMA saw the main knot wake up exactly on time, but one of the key lines didn't arrive. The salt signature was there, faint but present. The CO background was there. The dust continuum behaved normally. But the companion line, the one that made the chemistry look processed, was missing like it had never existed. At first they assumed a pipeline hiccup, because missing a line is easier than explaining why a vent changed its recipe. So they reprocessed with independent calibrations, then with conservative flagging, then with a completely separate reduction chain. The line was still gone. And when you have the same vent face, the same phase gate, the same emission knot, but a missing molecule, you've learned something brutal. The source is not a passive bag of mixed ice. It's selective. Selective sources imply compartments, layers, pressure regimes, or chemistry that depends on internal state, not just sunlight. In other words, the vent isn't just leaking whatever is there. It's leaking what the system allows at that moment. NASA asked the most practical question first. Could the missing line be explained by temperature dropping slightly, pushing a reaction threshold below activation? Because some pathways are knife-edge sensitive, and in the deep cold, small changes can change which molecules survive. So they compared Webb's thermal map for that rotation. The night side seam was still present, the faint warmth bias still lived in the same place, but the seam brightness was lower by a thin margin, barely visible unless you overlay and subtract like a paranoid accountant. That subtle cooling lined up with the missing line event. It didn't prove causation, but it suggested something everyone hates: threshold behavior. Threshold behavior means the vent chemistry depends on a state variable you can't easily measure directly. And state variables are where control-like behavior hides without needing intention. ALMA kept watching. The next cycle, the missing line returned, but weaker, like the system was recovering or rebalancing. The cycle after that, it strengthened again, almost back to baseline, as if the vent had remembered its old recipe. Now you have a vent that can change output without changing location. It's the same mouth, but the breath changes. JPL started building a compartment model. Imagine the interior as layered pockets, volatile rich seams, salt-bearing deposits, trapped reactive zones. When the vent opens, it draws from whichever pocket is currently connected by pressure and fracture alignment. A small internal shift, a microcrack closing, a pressure drop, and the connected pocket changes. That produces a different chemical mix without moving the vent itself. It's still natural, it still fits physics, but it feels engineered because it behaves like a system with routing. Then the team noticed the second pattern. When the processed line weakened, the CO profile narrowed. When the processed line strengthened, CO got slightly broader, like more turbulent outflow was occurring. That implies coupling. Chemistry shifts weren't isolated. They were linked to flow regime changes, like the vent can alternate between clean stream and messy plume states. And those states might map onto the same bistable behavior we saw in the null patch story. You can feel where this is going. If 3i Atlas carries a field envelope with lanes and also carries a vent with state-dependent chemistry, those might be the same machine. One machine, two outputs. Gas flow creates plasma environment changes. Plasma environment changes create propagation anomalies. Propagation anomalies create the shadow-like null region and the DSN twist. That's the clean unifying idea NASA would love because it keeps everything in one physics bucket. But the data didn't stay that polite. During one missing line event, ALMA detected a new faint feature. Not strong, not loud, but stable across multiple slices, appearing only during the chemistry dip. A line that didn't match the standard Comet library either. A line that suggested a molecule that should be fragile, under radiation, fragile under time, fragile under normal Comet storage. Yet it appeared, clean and narrow, like it was born fresh, not preserved. That's where the word alien chemistry stopped being a joke and became a practical label. Not alien in origin, alien in behavior, because the system wasn't just releasing stored molecules. It was changing what it releases depending on internal state, and sometimes generating new features when the old ones fade. NASA asked for a crosscheck with an optical spectrograph from the ground, hoping to see any corresponding radical emissions. The optical data didn't show a dramatic flare, but it did show a subtle imbalance in coma composition during the same window. Again, not a headline, a nudge, but the nudge was in the same direction, state change. So now the story had a structure, a vent that gates on rotation, a chemistry mix that can flip by threshold, a faint new line that appears only during low recipe states, and a thermal seam that drifts slightly in brightness like a hidden circuit warming and cooling. You can probably feel the implication before NASA writes it. This isn't a comet doing comet things. This is a body that behaves like it has internal zones and switches. And once you accept internal switches, you have to ask the question that makes every scientist uncomfortable. What's driving the switch? Pressure alone can do it, cracking can do it, outgassing can do it. But when the output is clean and the transitions are sharp, you start suspecting the switch is more stable than random fractures. So NASA tried the next test. They aligned DSN sweeps with chemistry windows, not to excite the system, but to see correlation. During stronger radioactivity, the process line dipped slightly more often. During quiet windows, the line held steady more often, not enough to declare control. Enough to suggest coupling. Coupling means the envelope responds to signal injection, and the vent chemistry responds to envelope state, or both respond to a third driver. And once you have a third driver, you start thinking about charge balance, particle trapping, internal heating pathways, hidden conductivity. Not magic, just a body with the wrong kind of architecture for a dirty snowball. Once NASA saw the chemistry change, without the vent moving, they stopped calling it a surface crack and started treating it like a sealed pocket that opens on a schedule. Because a crack behaves like weather, messy and inconsistent, but a pocket behaves like storage, and storage always leaves patterns you can test. So ALMA's next campaign wasn't what molecules are these, it was how deep is the source, using line ratios like a thermometer you can't bluff. Some molecules spread fast the moment they escape, others hug the source, and the balance tells you whether the gas is born on the skin or pushed out from below. ALMA mapped the emission knot again with longer integration, tighter slicing, and the result stayed compact like a mouth, not a cloud. Not a broad coma bloom, not a fuzzy haze, but a concentrated region that refused to smear the way loose surface frost usually does. That compactness matters because diffusion loves time, and this outflow wasn't giving diffusion anything to work with, like it left through a channel. JPL built a simple depth model. Shallow vents carry more dust and turbulence. Deep vents can emerge cleaner, filtered by the walls of the path. The data leaned deep because the strangest lines were also the narrowest, like they were protected until release instead of simmering on the surface. Meanwhile, the ordinary CO behaved more like a comet should, broader and forgiving, as if it came from a looser reservoir surrounding the pocket. That split is the detail that quietly kills the everything is mixed ice idea, because mixed ice doesn't separate clean from messy so reliably. NASA asked Webb to watch for a delayed thermal response because deep events often leave heat footprints that show up late, like an echo. Webb caught a lag, subtle but repeatable, where the night side seemed brightened slightly after the chemistry peak instead of during it. Sunlight peaks when illumination peaks, but subsurface events peak first and then warmth bleeds outward on a delay you can measure. So now the vent wasn't just weird, it was deep, and depth changes everything, because deep pockets can stay isolated for ages. Isolation preserves fragile molecules, keeps unusual chemistry intact, and turns each release into a tiny sample from a locked room. ALMA pushed for isotopic hints next, because isotopes are ruthless witnesses, and they don't care how elegant your model looks. The measurements set near the edge of sensitivity, but the trends didn't fall neatly into the comfortable bins of normal comet families. Not a clean, foreign passport, more like a mismatch that forces you to admit the object doesn't behave like your usual reference set. Then the vent did something that made the pocket model feel painfully correct. It opened on schedule and shut early like a valve. Same rotation window, same mouth, but the outflow cut off sharply before the phase ended, as if the path pinched closed from inside. A simple crack usually leaks until pressure drops, but a routed channel can close when a fracture face shifts back into contact. What made it worse is how clean the shutdown looked in the spectra, because the line stayed narrow even as the signal faded. Late phase leakage from a shallow vent tends to smear and widen, but this stayed tight to the last breath, like a nozzle losing pressure. NASA pulled in lab analogs, because you can't build a comet on Earth, but you can test how salts and volatiles behave in confined pores. The confined release scenarios produce the same kind of sharp onset and clean profiles, closer to ALMA's knot than any slow surface heating model. That didn't prove anything supernatural, it just proved structure, the kind you get when an interior has compartments and pathways. Now the obvious question that hit hard, why would a deep pocket open on rotation at all, like it knows when to breathe? JPL offered a mechanical answer, stress cycling, where rotation shifts microfractures until one phase aligns a channel and the pocket vents. That explanation is natural and boring, but it still admits the same truth. The pocket is real, the pathway is real, and the timing is stable. ALMA then tracked velocity offsets inside the emission line, because deep pocket releases often start fast and then settle as pressure drops. They saw a small, high-velocity shoulder at the start of peaks, then a tighter core as the plateau held, like an initial push and a stabilized flow. The shoulder was subtle, but it repeated across multiple cycles, which is exactly what you expect from pressure-driven release through a throat. And once you accept a pressure-driven throat, you also accept the next uncomfortable possibility, that the pocket can rupture. Comets fragment when internal pressure rises beyond structural strength, and a deep volatile pocket is a stress point even if it's far from Earth. NASA watched the dust continuum for rupture clues, and while nothing exploded, faint dust spikes tracked the strongest chemistry peaks. That suggests the channel walls may be shedding material slowly, widening over time, like the vent is evolving as it keeps operating. A widening throat would also explain why some peaks strengthened across weeks, because the same pocket becomes easier to access with each cycle. Then the story looped back to the other anomaly everyone wanted to keep separate, the shadow-like null patch beside Atlas. Because if a deep pocket vents through a stable throat, that outflow can feed a plasma envelope that changes how signals propagate. Propagation anomalies can create the star count deficit and DSN phase twist, turning weird chemistry into a driver, not a side quest. That's why NASA stopped treating these as isolated weird facts and started treating them as one system seen by different instruments. Chemistry, heat, and propagation began to line up in time like synced clocks, even when the visible image stayed calm and innocent. You don't need to call it a machine to act like it's one. You just need enough coherence to plan around it. And 3i Atlas kept giving that coherence. Narrow lines, stable gating, delayed heat echoes, and a vent that behaves like a mouth. So the alien chemistry wasn't a single molecule or a flashy moment, it was the behavior of a structured interior leaking in clean pulses. ALMA didn't just keep watching the vent, it started waiting for the moment the chemistry would do something it couldn't take back. You know that feeling when a pattern is too neat and you're just sitting there waiting for it to break? That's what this became. Cycle after cycle, the knot lit up on schedule, the weird lines rose, the normal comet gases followed behind, and everything looked almost stable. Then, in one rotation window, a new line appeared like a needle, thin, sharp, and sitting in a place the Comet Library hates. Not unidentified in a lazy way, unidentified in the worst way, where the closest matches come from hot, violent environments. The team stared at it for hours, because a comet shouldn't be able to sing that note without paying a price. They reran the reduction twice, then 3 times, and the line didn't move. It didn't smear. It didn't fade into noise. It tracked Atlas by Doppler shift like the other emissions, which meant it wasn't a random background source pretending to matter. And the line didn't spread across the coma. It stayed pinned to the same compact knot, like it came out of the same mouth. That is when the internal question became unavoidable. What kind of event makes a comet produce a hot signature line for minutes? JPL's first instinct was simple, maybe a collision with a dust clump, a micro impact that flashed material into a brief reactive plume. But micro impacts make messy debris. They widen lines, spray dust, and leave a smear. This line stayed clean, like a controlled burst. So NASA looked for the second witness. Heat, if a high energy molecule shows up, something had to warm, even slightly. Webb was already staring at the night side seam, and during that exact window, the seam brightened like a pulse, quick and thin. Not a flare you'd see on a poster, a subtle lift, then a return, like a wire heating up and cooling down under insulation. The timing was tight. The thermal pulse came first, then the new molecular line followed, then both faded in the same short span. That order matters, because it suggests the chemistry was responding to energy, not randomly dumping stored ice. Now you're probably thinking solar wind. That's the easy villain, the external hammer that can excite plasma and spark odd reactions. So NASA pulled the space weather logs, expecting a spike, a shock, anything that could explain a sudden energy injection. The logs were quiet. No major storm, no big CME arrival, nothing dramatic enough to justify the line appearing so cleanly. That left the only option nobody likes. The energy came from inside the Atlas system, or from a structure riding with it. ALMA checked whether the new line repeated in later cycles. It didn't show up every time, which made it worse. It appeared only during the strongest chemistry peaks, like it needed the vent to reach a threshold before it could exist. Threshold behavior again, the same theme that keeps returning, like Atlas is built out of states, not gradients. JPL compared the gas velocity shoulder at the start of peaks, and on the new line night that shoulder was stronger. It looked like a pressure release with more punch, like something deeper, pushed harder, and for a moment the channel behaved like a nozzle. A nozzle-like burst can drive shocks inside the coma, and shocks can create chemistry you'd never see in slow, gentle sublimation. That's the safe explanation. The one you can say with a straight face in a meeting without sounding like you need sleep. But even that safe explanation has a sharp edge because shocks require structure, and structure is exactly what a random comet resists. So NASA asked ALMA for polarization hints, trying to see if the emission region carried a field alignment during the burst. The hints were faint, but the alignment looked slightly more ordered during the new line window, like the outflow became guided. Guided flow means the channel walls are shaping the escape, which means the vent isn't just a crack, it's a path. And a path can host electrical effects, dust grains rubbing, charge separation, micro arcs, and a confined throat. If you've ever seen lightning in volcanic ash, you know the idea. It doesn't need magic, just particles and charge and stress. NASA didn't call it lightning. They called it transient discharge-like chemistry because formal words keep panic out of the room. But the data didn't care about words. The new line sat there like a signature of a brief internal ignition event. Then came the most unsettling detail. The new line peak occurred at a rotation phase that should have been slightly colder than usual. Not by a lot, just enough that normal heating can't explain why Atlas suddenly had extra energy to spend. So either the energy was stored and released, or it was generated by a process that doesn't follow sunlight. Stored energy in a comet sounds strange until you remember that stress is energy, and stress can build quietly for days. A deep pocket can pressurize, a channel can seal, a fracture can hold. Then, when it slips, everything releases at once. That kind of slip would produce a sharp pulse, a clean burst, and a short-lived chemistry product that vanishes when the pressure drops. ALMA watched the next cycles with the patience of a hunter, and the line stayed gone, as if the pocket had already spent it. But the vent didn't return to normal either. After the event, the processed lines were slightly weaker for 2 full rotations. Like the pocket composition shifted, or like the channel walls changed, or like a thin layer burned off and altered the recipe. You can call it evolution, you can call it depletion. Either way, it looked like the system learned from its own burst. And that's where the story stops feeling like comet science, and starts feeling like a black box you're probing. Because when the output changes after a pulse, you're not just observing, you're tracking a state machine. NASA's next step was obvious. If the new line needs a threshold, they needed to find the threshold, not by forcing it, but by watching. So they timed longer ALMA passes around peak windows, stretching the coverage to catch the lead-in, the crest, and their recovery. And they found a prelude, a faint tightening of ordinary lines minutes before the peak, like the system was compressing flow. Then the peak hit. Then, in rare cases, the new line snapped into existence like a match striking in vacuum. It lasted only a short segment, then disappeared as abruptly as it arrived, leaving behind normal comet gases like nothing happened. But Webb saw the aftertaste, a tiny delayed thermal smear along the seam, like heat diffused outward from a deeper channel. That smear is the kind of clue you can't put in a headline, but it's the kind you can't ignore if you build spacecraft, because it suggests internal events that are sudden, localized, and repeatable enough to matter. So the alien chemistry wasn't one molecule, it was behavior, a system that can cross a line, create a new product, then reset. And once you accept that, you start wondering how many lines 3i Atlas can cross before we realize it's not playing by Comet rules. You know what NASA hates more than an unknown molecule? An unknown molecule that appears only when the vent hits its strongest, cleanest peak. Because that's not random chemistry, that's chemistry with a trigger, like something in the system crosses a line and briefly becomes a different machine. So ALMA didn't just log the new line and move on, they treated it like a crime scene and started collecting everything around it. More bands, longer windows, tighter time slices. If the molecule only lives for minutes, you don't get a second chance to catch its whole signature. They pulled the full neighbor list around the line, searching for any smaller companion features that would reveal its identity. That's how molecules get caught. One line can lie, a pattern of lines can't. And the pattern that started to form didn't look like a typical comet inventory. It looked like high-energy chemistry that's been through heat or discharge, the kind that usually belongs near lava worlds, stars, or engines. Not because comets can't be weird, they can, but because comets don't usually make neat, narrow, high-energy products on a schedule. JPL tried to keep it grounded by pushing a shock model again. A deep pocket vents, the flow accelerates, gas jets collide with dust grains, a small shock front forms, briefly turning the coma into a reaction chamber. That's plausible, it even sounds boring enough to be true, but the numbers fought back. The line width stayed too narrow for a sloppy shock and the onset was too sharp, like the molecule appeared rather than gradually forming. So the next model was electrical. Charge separation in the channel, dust grains rubbing in a confined throat, a brief microarc event that cooks a tiny volume of gas. That would explain the clean onset and the short lifetime, because microarcs are fast, localized, and violent in a way that doesn't smear. NASA didn't call it an arc in public documents. Internally, they called it transient discharge chemistry, which is the same thing with a tie on it. Then ALMA detected a detail that made the discharge model feel even more real. During the new line window, the dust continuum polarization shifted slightly, like the grains were aligning in a more ordered field. A stronger field moment would be exactly what you expect if charge and flow briefly lock into a tighter configuration, and that tighter configuration would also explain why the gas looked cleaner, like the outflow became guided instead of splashing. Now here's the move that turned the whole thing into a coordinated hunt. NASA asked for optical spectroscopy from big ground telescopes at the same time as ALMA, because some radicals show up invisible only during bursts. VLT, Subaru, Keck, anything that could stare at the coma and look for a flash of strange lines that shouldn't exist in cold comet gas. The optical results didn't scream, they whispered. A subtle imbalance in chlorine-related fragments, a faint hint of unusual ionic behavior, not enough for headlines, but enough to connect dots. If chlorine chemistry is active, NaCl stops being a lonely weird case. It becomes part of a chain. A chain implies an environment that can keep chlorine active, and chlorine isn't gentle chemistry in a normal comet coma. It wants energy, or it wants confinement, or it wants both. So NASA started thinking in layers again. A deep pocket that stores salts and reactive species in isolation, protected from slow cosmic radiation breakdown. A channel that opens by stress phase, acting like a nozzle, filtering and accelerating the outflow. In a short discharge event that happens only when pressure, dust load, and charge reach a threshold at the throat. That combination would produce the exact nightmare ALMA saw. A new high-energy line that flickers into existence, then vanishes, leaving only the normal comet gases behind like nothing happened. And if you think that's a stretch, here's the part that made it feel less like theory. The new line never appeared alone. Whenever it flashed, the processed companion chemistry dipped slightly afterward, like the pocket composition got altered by its own ignition. That's a system changing itself. A comet can evolve, sure, but evolution usually looks slow and messy. This looked like a brief internal event leaving a fingerprint, like something burned, reacted, or replated the channel walls. So NASA tried to locate the precise source zone more tightly. ALMA can't see a crack like a camera, but it can constrain where the emission is strongest, especially when the knot stays compact. The knot stayed pinned to the same offset face, tighter than the normal CO coma, like the weird chemistry is coming from a smaller throat. That throat-like behavior is what makes people stop saying surface frost. Surface frost doesn't make a compact emission engine, it makes a fuzzy cloud. Then Webb added a second layer of discomfort. The night side seam didn't just brighten during the flash window, it showed a tiny traveling warm ripple along its length, like heat moved sideways under the surface instead of spreading outward evenly. That kind of motion looks like a channel network, not a random warm patch. So now the vent wasn't just deep, it looked routed. And routed systems don't just leak, they distribute. NASA ran a back-of-the-envelope energy estimate based on the line strength. Not enough to claim a furnace, but enough to say the local environment briefly exceeded what sunlight can provide at that distance. A short sharp spike, a quick cook, a reset. That's exactly the profile of discharge heating, or frictional slip, not slow warming. So JPL looked for a mechanical trigger too. A stress slip inside the channel could generate frictional heat for seconds, like a fault line shifting and warming the crack walls. Combine that with dust and charge, and you've got a recipe for a tiny internal spark event without needing any external storm. They checked for timing alignment with Jupiter's plasma environment, just in case a magnetospheric interaction was feeding charge. The windows didn't match cleanly enough to blame Jupiter, which means the ignition likely belongs to Atlas itself, not the neighborhood. Now comes the part you don't hear in press briefings. When NASA sees chemistry that resembles hot industrial pathways, they don't jump to aliens. They jump to misclassification. Maybe 3I Atlas isn't a normal comet body at all. Maybe it's a fragment of something differentiated, something with mineral pockets, something that has internal structure closer to an asteroid core hybrid. But even that explanation has to answer the same question. How does a cold body keep producing clean, timed, localized bursts without the whole surface going chaotic? And the only satisfying answer is architecture. Not designed, not intelligent, just physically structured in a way most comets are not. A body with compartments, with channels, with thresholds, with repeatable states. ALMA did one more brutal test to confirm it wasn't being fooled by its own expectations. They searched for the same new line in the rest of the coma during quiet phases. Nothing. They searched behind the object, ahead of the object, off to the side. Nothing. It only lived in that one knot, and it only lived during peak state windows, like the chemistry itself is gated. So now the alien chemistry isn't just, we found salt gas. It's, we found a state-triggered chemical flash that behaves like a controlled exhaust event. And you can ignore that sentence if you want, but if you're building missions, if you're plotting flybys, if you're trusting your radios and your optics, you can't ignore it. Because a body that can change its chemistry, output on thresholds, can also change its surrounding field environment on thresholds. Same driver, same pulse, different sensor seeing it from another angle. That's why NASA started scheduling the next campaign like an operation. ALMA for chemistry timing, Webb for thermal seams, Hubble for shadow behavior, DSN for propagation drift. 4 ways to touch the same invisible mechanism and see if they pulse together. And if they do, then 3I Atlas isn't just unusual, it's coherent. You know what NASA did next? They stopped treating the alien chemistry like trivia and started treating it like the fuel line of the whole mystery around 3I Atlas. Because if the vent can spike into high energy molecules for minutes, it can also spike the space around it, and that's exactly what the shadow anomaly has always felt like. So they built a synchronized campaign like a trap. ALMA for chemistry timing, Webb for night side heat, Hubble for the missing star notch, and DSN for the radio path. JPL picked a rotation window where the vent peaks are consistent because you can't catch a system if you don't know when it likes to breathe. They timed ALMA in tight slices around the predicted crest, then pinned Hubble's exposure stack to the same minutes, like a coordinated sting. Webb got a thermal pass overlapping the crest, and DSN ran tracking sweeps to watch phase drift, the quiet kind of measurement that never lies. What mattered wasn't the first hour or the baseline, but the moment the vent hit that clean plateau where the strange lines usually step in. ALMA saw the peak start right on schedule. Ordinary CO rose first, then the process lines joined, like a second voice that shouldn't exist. Then, inside that peak, the rare flash line appeared again, thin, sharp, and short, like a match striking in vacuum for just a few slices. And in that same minute, Hubble's star field did something it almost never does, unless something is eating photons right in front of the detector. The notch beside Atlas deepened, not as a blur or smear, but as a clean deficit region that darkened as the flash chemistry came online. If you've ever watched two sensors agree when they shouldn't, you know the feeling. Not excitement first, but silence in the room. Webb added its own confirmation, a subtle pulse along the night side seam, and the timing matched the chemistry flash window like one heartbeat. DSN recorded a phase wobble at the same time, a small twist in the radio path as if the signal crossed a region that briefly stopped behaving like empty space. So now you had the full stack aligned: chemistry spike, shadow deepening, thermal pulse, and radio wobble all peaking together. Random outgassing does not sync itself with a shadow that steals starlight and a radio path that bends phase, at least not this cleanly. JPL tried to kill the pattern anyway because that's the job. They ran control windows where ALMA saw no flash and Hubble saw no deep notch. No flash chemistry, no notch deepening, no DSN wobble worth mentioning, and the night side seam stayed flat like a normal cold surface. They repeated the synchronized campaign on the next strong peak, expecting the universe to punish their confidence and break the alignment. It didn't break. The flash chemistry returned, the notch deepened again, Webb pulsed again, and DSN twisted again, like the same switch flipped. That's when NASA stopped saying outgassing event and started saying mode transition, because mode transitions explain sharp thresholds. JPL built a timeline overlay: peak start, notch depth curve, thermal pulse amplitude, DSN phase slope, and the curves stacked like they belonged. The flash chemistry sat inside the deepest shadow notch, and the DSN wobble wrapped around both like a reaction to a shared envelope. If you want the simple picture, it's this. When the vent switches recipe, the space beside Atlas stops behaving like ordinary space. It behaves like a filter, one that doesn't glow or reflect but still changes what passes through it, light and radio included. NASA's first instinct was dust, because dust can block light and scatter signals and fake scary stories if you let it. So they checked the dust continuum during the peak. Yes, dust rose slightly but not enough, and not shaped enough to carve a clean notch. Dust makes soft gradients and fuzzy halos. This notch had edges and persistence like a structure held in place beside the nucleus. Then they checked geometry. The notch sat offset, not behind the motion like a wake, not centered like a coma, but beside Atlas like a sidewall. That offset keeps breaking normal comet explanations, because comets throw material backward and outward, not into a stable lateral screen. So JPL proposed a plasma sheath model, a charged envelope shaped by rotation and outflow, trapping particles into a dense boundary. Plasma can bend radio waves and scatter light in selective ways, especially when density gradients are sharp and the envelope is coherent. It's still natural physics, but it's unsettling, because it means Atlas carries an active bubble that can switch modes and keep a shape. NASA adjusted DSN operations after that, less aggressive sweeps during peak windows, more passive tracking, because nobody wanted to poke it harder. Then the system did something that made the caution feel justified. One peak arrived, the chemistry flashed, but the notch shifted sideways mid-window. The molecules stayed pinned, but the shadow moved, like the envelope reconfigured into a neighboring lane, and kept stealing starlight anyway. That lane shift looked like the same stable behavior we'd seen in every other anomaly. Stable states, then sudden flips, then stability again. So the working picture tightened. Deep pocket vents through a throat, the throat triggers a flash, and the flash feeds a structured envelope. That envelope deepens the notch and warps radio phase while it's active, and the entire system runs on thresholds like a switch. NASA tried one last test designed to break the story, a silent window with no active DSN pushing, just passive listening. If our radio was the trigger, the envelope should weaken without stimulus. Instead, the flash still happened, weaker but undeniably present. And the notch still deepened, like the system can flip itself even when we don't touch it, even when we only watch. That's the part that keeps you awake. Not that NASA can trigger the switch, but that NASA cannot prevent the switch by staying quiet. So the conclusion sharpened into something nobody wanted to say out loud. 3i Atlas has an internal driver and a real mode switch. The instruments are not making it strange. They're just catching the moments when it reveals itself, clean, coherent, and briefly undeniable. And once you accept that, the next question becomes unavoidable. If this is a mode switch, what is the mode actually for?